Hello students, let us now try to solve an important problem which is interesting too and which is very important with respect to your IIT mains and IIT advanced, as well as all your competitive exams like BITSAT, CETs, MHCT and all these exams. Let's see what is the problem about. If you look at the question, they're asking us to find the value of x, and this is one question which is repeated in your JEE exams before, so I've marked it so that this is an important problem. If you notice the question, in the question they have given x is equal to cube root of 2 plus root of minus 121 plus cube root of 2 minus root of minus 121. If you notice, they have given question in such a way that student gets little panicked looking at the question the way they have given, but it's actually very simple. Let's try to simplify it and write it first, and then let us try to find the value of x. Now what do we do first? I will write my x as cube root of 2. We know that how do we write root of minus 121, children? We can write root of minus 121 as 121 into root of minus 1. So we can easily write it as 2 plus 11i, because you will write 121. What do you write? 121 you write it as minus 121 will be written as 121 into minus 1. So this is both the terms under root. So you can write root of 121 as 11, root of minus 1 becomes I. So you write it as 11i. So this is very important step. Then the next term will be written as cube root of 2 minus 11i. Same way, minus 121 is written as minus 1 into 121, whereas both are under root. So root of 121 becomes 11, root of minus 1 becomes I. So we got x as cube root of 2 plus 11i plus cube root of 2 minus 11i. If you notice the question, now question is already simplified. Now this looks like a complex number where if you take this as z, 2 plus 11i as z, this will be your z bar. You can notice we have discussed about a conjugate. What is a conjugate or a rationalizing term? It is deferred by the given complex number by the term. In the given complex number, it will be of the form x plus iy, but the conjugate will be of the form x minus iy. You can notice that this is of the form x plus iy, this is of the form x minus iy. So this looks like the conjugate. So I can write the given term as z. I'll write this term inside the bracket as z. So I can write z is equal z plus z bar. I can take the term inside the complex as z. So this is nothing but cube root of z plus cube root of z bar. We can write the given question as cube root of z plus cube root of z bar. Now after this, what do we do? Concentrate here, students. Concentrate on this part of the problem, which is very important. If you look at this now, z, cube root of z can be written as, what is cube root of z? You are finding cube root of z, but in the place of z, what do you have, children? Just focus here. We have written z as 2 plus 11i, right? So in the place of cube root of z, we have cube root of 2 plus 11i. So what is my z? Z is 2 plus 11i. So this is your complex number. I'll take it as z. Basically, what you want to find? You want to find cube root of z, correct? So you have to find cube root of z. So what is given is z, which is 2 plus 11i. Let's take it this way. Now, if I assume my z as x plus iy, because I want to find cube root of z. So I can write my cube root of z is equal to x plus iy. Focus here. Cube root of z is x plus iy. So what is my z, children? You can write z as x plus iy the whole cube, isn't it? Because you know we have written z as 2 plus 11i. Cube root of z is x plus iy. Let us assume cube root of z, because we are finding the cube root here. You require cube root of z and cube root of z bar, that is conjugate of z. So let us assume this cube root of z as x plus iy, because we know a complex number, cube root of a complex number always will be a complex number. So let us assume that x plus iy is the cube root of z. So in that case, what do we do now? I've taken cube on both sides. Cube root cube gets cancelled. X plus iy the whole cube. We have the identity. We have an identity which is a plus b the whole cube. What is the identity a plus b the whole cube, children? Focus here. It's a cube plus b cube plus 3a square b plus 3ab square. This is the identity we are going to use now. So if I am using this, let us substitute 2 plus 11i in the place of z, and here it becomes x cube. And you know what do we write? Iy the whole cube. I will write this is iy the whole cube plus 3a square becomes 3x square into iy plus 3x into iy the whole square. If you notice here, let us substitute the value. We know the powers of iota. Now if you notice, I cube is minus I. So I will write x cube minus y I. X cube minus y cube I plus, here it is 3x square y into I. You have two imaginary terms here, two terms associated with I, and next one will be 3x into I square into y square. You know I square is minus 1. So I would write this as minus 3x y square. And if you notice, it is only two terms which is a real part here. Why? Because you know when we are equating a complex number, the real part of the complex number will be equal to the real part of the complex number. The imaginary part of the complex number will be equal to the imaginary part of the complex number on the other side. Now I will take I common from my second terms, which I have taken minus I common. If you take minus I common, what is remaining is y cube minus 3x square y. This is what we get here. If you notice, we got 2 plus 11i equal to x cube minus 3xy square minus I into y cube minus 3x square y. Is it clear, students? Did you understand till here? If you notice, what do we have here? My complex number is now equated to x cube minus 3xy square minus I into y cube minus 3x square y. If you make it plus, this will become minus, this will become plus. Only that is a change. Now let us try to simplify this further, equating the real part of the complex number with the real part of the complex number. So I can equate my 2. You can notice here 2 can be equated to x cube minus 3xy square. You can notice here 2 can be equated to x cube minus 3xy square. So I can further simplify and write this as x into x square minus 3y square. I got the value of x into x square minus 3y square. Now let us equate the imaginary part with the imaginary part. What do we have? In the place of 11 we have, what do we have, children? See, since here minus sign, here it is plus sign, we'll take minus sign along with the complex number. So that would become 3x square y minus y cube. This is equal to 11. So I'll write my 11 as, taking y common here, it becomes 3x square minus y square. You can notice here, what do we get? 11 as 3x square minus y square. So now we got two equations. If you notice, we got two equations here in terms of x and y. So what do we do after this? Now you know that we have to find the value of x plus iy. Once you get the value of x plus iy, you are going to find the value of x plus iy plus x minus iy, because x plus iy is a cube root of 2 plus 11i. So x minus iy will be cube root of 2 minus 11i. So we know this. Now, how do we simplify this further? If you notice, the common terms what you have here is x square minus 3y square. Here it is y into 3x square minus y square. So we know the simplification part here. How do we simplify? Look at the students. We have written what is x into x square minus 3y square, which is equal to 2. Now we can easily solve this. Instead of simplifying it further, how do we solve this? We can go for trial and error method, where you know you can get the value 2 when substituting this, and what you have to substitute in the place of x, that you need to know. Because if x is 1, then 1 minus 3y square will be negative. So let us try to substitute one value. I will try to substitute the value of x as 1, y as 2. Let's check, is it possible? When you substitute x as 1 minus 3 into 2 square. No, you're not getting 2. If you substitute 2 and 1, x as 2. If you substitute x as 2 and y as 1, this is 2. This is 4 minus 3 into 1. So what are you going to get? This is by trial and error method. I can write this as 2 into 2 square minus 3 into 1 square. So it is going to satisfy the value. So it is going to give you 2 into 1. So I can substitute x equal to 2. So I got the value x is 2. When x is 2, what is y? It is easy to substitute here and get the value of y, because we have already taken a trial and error value which is 2 and 1. So we can easily write cube root of z as 2 plus I. And if you notice, we have cube root of z. What is cube root of z bar? We got x plus iy. What is x minus iy, children? It is 2 minus I. This is cube root of z. So x value is nothing but x is cube root of z minus cube root of z bar. So I can write it as x plus iy minus, sorry, x plus iy plus x plus iy plus x minus iy, which will give you 2x. And here if you look at this, it will give you the value 2 plus I plus 2 minus I, because cube root of z we got it as 2 plus I, which is cube root of z bar will be 2 minus I. So I will write it as 4. So 4 is the value of x, what you're getting. It is not this x what you have substituted, it is the x in the question. So don't get confused. What is the value of x we are getting here? It's 4. So this is how we solve. In this problem we have also covered how to find the cube root of a complex number. You can notice, if suppose it was only given find the cube root of 2 plus 11i. How would you solve this? You would write the cube root of 2 plus 11i as 2 plus I directly. How? You would take cube root of z as x plus iy. You would have taken cube on both sides. Then you would have solved this using trial and error method. So this is one of the way of solving cube root of a complex number. So always try to understand, children, whenever we are solving cube root of a complex number, we follow this method. We use the identity a plus b the whole cube. So this is one of the important, interesting and a repeated JEE question.